Okay, here we go. So it says it gives you the information to complete the table. We looked at, I think, a problem like this a week or two ago. They don't give you all the numbers, they give you enough to find all the numbers. So it says 54 bearded dragons prefer eating. So I guess we're supposed to assume those are men. Male beardy. Okay, there they are. Male beardy prefer eating. So that would be like these. And then 23 females prefer eating in the morning. So I guess the no means they're not male. I guess we'll take that as female. And then eating in the morning means not the evening. So I would guess this is 23. It's written pretty oddly. I mean, it's definitely not helping you much.
Yeah.
To do this. We do seem to be missing totals. Is there any more information than this? Maybe from the other side, it was another example of bearded dragons and they gave you the total, or maybe you're supposed to assume it's 100. We need something else. We don't have enough information to be able to do this.
That's a good question.
It looks, I don't know, if what I think is page 1, I don't see any more information here. Sorry, I'm just going through the questions. Complete the toy table.
I don't know if it's the question on the front where it talks about is it studying the eating habits of bearded dragons has ordered 45 males and 45 females to work with?
That could be helpful.
I think it is because it talks about that Riley wants to learn 2 things.
Okay.
So I think it says Riley will analyze data from 30 bearded dragons. But that doesn't line up with the data on the second page.
Yeah. Okay, so let's just forget that part for a moment, unless you're submitting this for a grade. But we can do the rest of this, but it would be good to just get some numbers here so we can answer the questions. Is that okay?
Yeah, it's just a study guide for review,
Okay.
so I don't think it matters too much.
All right, so I'm just making up numbers here. I'm not giving this much attention, but I'm going to make it out of 100 to make it nice for us. So this is 30 and 70. And if that's okay with you. All right, so now we can answer these questions. The whole point of filling in the table is so that you can answer questions. What is the probability that a bearded dragon taken at random prefers evening meals? So how many bearded? This is so weird because I guess I don't even know what it's male beardy. I don't know what that's. I don't know if they're all bearded dragons and this is just the males. I guess that's what I want to do. I want to say these are just males, or okay. Male and then female. I don't know. It's a little weird, but okay. What is the probability that a dragon taken at random prefers evening meals? So it's like, how many evening meals are there out of the total?
Prefers evening.
Out of the total, yeah. So sorry, I already jumped in there. Yeah, there's 50 that like the evening meals out of the total. If you know a beardy is a female, so that's really important. It says if you know a beardy is a female, that restricts you to either a column or a row. In this case, it's the column here of the females. What is the probability it prefers morning meals? Basically, it's like how many of these 30 are the mornings? And you almost need to like rewrite this. It's like evening, yes, morning is really what the second one is on the bottom. The no really means morning.
So 25.
25. And then you should reduce, I don't know what your instructor will have you do, but let's do that. Now let me grab a snip of this table that I've got, and then we'll look at the next questions here for this. So let me grab this. Here's that. And then let's grab the next question here about if you do something with a male in the morning. Okay, if you feed a male in the morning, what is the probability that he will not like it? It's written kind of awkwardly. So we're looking at the males.
Mhm.
So there's 70 males. We want the ones that are being fed in the morning, I guess.
So the ones probably he won't like it. So if it's in the morning, male. So 25 out of 70.
I think so. It's written kind of oddly. These aren't straightforward. It's more about the English language, but you could also interpret this as a male in the morning is the 25. And maybe that's referring to some of the given information. I would say we should probably just move past this one.
Okay.
Okay. So what I was looking here for was more like, what's the probability that a male prefers evening? That's probably a more important question to be able to ask. A male prefers evening. So how many in this table are actually male that prefer evening?
Male, 45 out of 70.
So it's actually out of 100, because it's the whole group. It would see like probably that a dragon is male and prefers evening.
Okay.
So this type of problem I'm giving you here is sometimes you're looking at one cell of the table. Okay, and those are usually and situations. So sometimes you see that symbol there for and. Have you seen that from class?
Yes.
Okay, now just looking at this table again, let me snip it down, try ask another question. So the next one is generally an or situation. What's the probability that a dragon prefers morning or is female? Prefers morning or is female. So the or is that union operator. So there's 100 total, but how many, and this is almost where you're identifying which cells. So the or is generally 3 cells. There's like an overlap, but you just use 3 cells. So can you tell me which 3 cells correspond to morning or female?
Prefer a female and prefers morning. I would say the female. Okay. Wait.
So I'm basically asking, I'm just going to color code these just to be clear here. I'm asking which of these cells you're using. Of those 4, which of those 4 you're going to use 3 of those 4?
I would say the 25.
Okay, 25.
25 plus. It's a female or prefers the morning.
Yes.
Morning. The other 25
Yes.
and
which else?
the 5.
Yes, that's perfect. So an OR uses 3 cells. There's usually some overlap.
Mhm.
and you do not double count. So the one that's overlapped, you just count once. So that's 55 over 100. Okay, so now the next type of problems that you would be given are conditional ones, and that's what it was kind of referring to, but they were just written so poorly, at least
Yeah.
for me, because I don't understand this. I mean, maybe this is something that the teacher is excited about and talks about in class, but I don't understand it. But the conditionals, they refer to either a row or a column. And there's some language in there for that. It'll say like if something or given something. That tells you whether you're restricted to a row or a column.
Mhm.
So for example, it would say like given the dragon is female, what is the probability that it prefers evening? So given the dragon is female, so that restricts you to a row or a column. Is it a row or a column in this case? That's female.
So a row or column.
Yeah, I'm asking which row or column is female?
Um, the no column.
Yes. So this is your world. This is what you care about. So that always changes. The conditional ones always change the bottom number to whatever the row total or the column total is.
Mhm.
All right. So the question now is which number do you want? Do you want the 5 or the 25? And that's where the second part is. It's what is the probability that it prefers evening?
5 out of 30.
Yes. Okay. So so again, that's the kind of the language you're looking for. We'll go the other way. So if a dragon does not prefer evening, and this is where I think the language the instructor was trying to use is a little bit awkward. The way it's written, it's either yes to evening or no to evening. So if they do not prefer evening, they actually prefer the morning.
Mhm.
So that's restricting this to this row. But there's like a few other ways to say it. Like it could say if a dragon prefers the morning. So the idea is that, well, if it's not evening, it must be morning. I don't know if that's fair or not, but that's what it is in this problem. And then it would
Mhm.
ask like, what is the probability it's male? So 50 on the bottom because that's the row total. This isn't a great example because they're both 25, but which 25 is it? Is it the left one or the right one?
Does not prefer evenings. It's
But
the right 25.
so the right 25 is for females.
The left one.
The left one, yeah. So the like you don't even care what's in the other spaces after you do this. I think it's that one there.
Okay.
Okay, so I think that's everything I can say about that. The question for here, I don't understand at all. I'll just snip it in. Maybe you have some idea. And then 5, 6, and 7 are sort of like self-discovery questions, but let me snip in this one. Oh, BD means bearded dragon.
Mhm.
Bok choy in the evening, or okay. So this takes so much effort to do. So let's take the first one here. It says a bearded dragon. So that bearded dragon chosen at random. That means you're looking at the whole table. The whole table. So that's over 100. is male, and the and is super important. That means the intersection. The intersection means it's one cell. So we're looking for one cell. So we're looking for the cell 45, 5, 25, 25 that is male and evening. This bok choy is irrelevant. Male and evening. Which one is that?
45.
45. Okay. And the next problem, either is like an or. Either or, maybe you remember that from a grammar lesson a long time ago. Union, that's when there's some overlap potentially. Okay, now it's a bearded dragon, so that's all of them. But we want the cells that represent female or morning, female or morning.
Okay, so female. Hmm. Well, if it's just female in general, is it 30?
So you want to add the cells together, 5 and 25. Yeah, that gets you to 30.
Oh,
That's
okay.
good. It is 30, but that's like, okay, I got those two. But which is the other one? Is it the 45 and 5 or is it the 25 and 25?
Female or prefers bok choy in the morning. Oh, it's the other 25.
Yeah, it's those right there. So you only add once. I think we already did this one, but we're doing it again. There it is. All right, so we've really hashed out that question. Okay, so can I go to the last page?
Could you explain the 6 and 7? I kind of get confused on that for the test.
Of course. All right, let's make a new thing up here. So let's go with dogs, cats, and we'll go white paws and not white paws. So we go to the local shelter. There's 6, 8, 9, and 13. And now I'm going to grab questions 6 and 7. I just think this will be more clear rather than
Yeah.
doing this stuff that they've been talking about. Now you do need to get the totals. So it's 14, 22, 36, 21, and 15. So this symbol right here means intersection. Okay, intersection. So an intersection means one cell, means the word and. It means both true. Okay, so can you think of a question where I'm asking for just one of the values in the cell? Like you go to the animal shelter, and what kind of thing did you adopt?
A cat that does have white
Okay,
paws.
so the probability of cat and white paws. And a lot of cats have white paws. You've noticed, so I don't know why. So that's 8 out of 36. Okay, so that would be this intersection. That intersection is the and, kind of looks like an A, but it's one cell. It's one cell that we're looking for.
Okay.
All right. Let me grab this table here. I mean, I hate saying it, but your teacher's probably not going to give you something like this that's kind of normal because the bearded thing was really weird.
Yeah.
Okay. I saw a test that had some reference to Jay-Z and him solving a math equation. That was also, I think, a little out of context. Anyway, the U means or could be written as either or. Okay. Union always refers to overlap, some sort of overlap. It's generally 3 cells that are overlapping. So can you give me an or statement about this animal shelter? Your friend wants to adopt a what? Either a blank or a blank.
So 3 cells.
Yeah, so like what it can't be is you can't say dog or cat. It has to be like a dog or has white paws, for example. Cat or has white paws. Dog or does not have white paws. Cat or does not have white paws.
Oh, okay. So, cat that does not.
Does not have white paws. So we got to be careful here with our language. Cat or does not have white paws. That or is really critical. So your friend either wants a cat or it can't have white paws. So now this one sounds weird too. So what I like to do is identify those cells, and you've seen me circle them a bunch of times. Like, okay, there's the cats, and there's the ones that do not have white paws, and that's the overlap that I'm talking about. The 8 plus 13 plus 9 over the 36.
Okay, that makes sense.
So you have to be able to reasonably distinguish between that U and that other one intersection. And
Okay.
it looks like an A. Like that. Okay, the bearded dragon continues. I don't know. I'm thinking of like Will Ferrell probably said something about bearded dragons or something. I don't know. So
Yeah.
there's something a little odd about this. Okay. Dragons in Riley's group produce an average of 49 grams of poop a week with a standard deviation of 7 grams of poop. Use a diagram of the normal curve to illustrate each of your answers. Okay. So the key takeaway here is 49 and 7. That's the mean. And the sigma is 7. So the first thing you've got to be able to do is draw this nice normal curve reasonably well. That's not very good. Something like that. And then you go right down the middle, and that's your mean.
Okay.
No, we're going to go out. We're going to spread out from the mean one standard deviation at a time, but you have to put them in the right spot roughly. Like this is reasonable. This is reasonable. There's places that are not reasonable. So have you seen an empirical curve on in your textbook?
Yes.
Okay. You want to have like a good mental image of that so that you're putting these in the right place. So you add one standard deviation and you subtract one standard deviation like that. And then you keep going here. So you keep adding and subtracting 63, 35, and then you do it again, and you get 28 and 70.
Okay.
So you have to be able to do that. It doesn't matter what scenario it is, whether it's weird bearded dragons or if it's just whatever it is, mean, a standard deviation, do that. Now the next thing, this is a little bit harder to do, is you have to know what percentages go in each of these. Do you know those values, or if you don't, how do you think you'll remember those?
I think one standard deviation is 68, and then it's 95 and 99.
So that's good. So we're going to use that here. So 68, that means that there's 34% in each. And you're right, it's 95. And the next one, so this is where it gets a little bit more difficult. You got to cut that in half, which is 47.5. And then you have to take away the 34, and that becomes 13.5. So what you've said is correct, but you have to be able to continue to like manipulate these things. So the last one is 99.7. You cut that in half, which is 49.85. And then you have to subtract out the 13.5 and the 34.
Okay.
And I'm struggling here because I'm tired. 47.5, 2.35. I think that's right. 2.35. And then in the ends is the 0.15 and the 0.15. Up to you. Maybe, you know, 68, 95, 99.7. You can remember those, but you need these numbers in the normal curve.
Okay.
Because that helps you to answer these questions. Like, you know, what is, so because the percentile is essentially asking you for the area left of 28.
Okay.
And just to be clear, these are all percents. So, you know, not to add yet another wrinkle, but you know, you got to be careful. You're like, it's really 0.34, 0.34, 0.135, and so on. Percentile refers to percents, though. So that's probably better done in another color. So the black numbers are percents. So that is your answer to this value of 28. It is the 0.15 percentile.
Okay.
Although, I'm sorry, I mean, maybe your instructor wants you to do the normal distribution calculation. I really can't tell. Apologize. So like another way to do this is to say, all right, there's 49, there's 28. What's the area in the curve here? And I think we were doing this last time. The norm distribution, norm dist. Do you remember that from whenever we last did this a week ago? Usually it requires the lower and the upper bound. I don't know, do you have your calculator handy for that?
Yes.
If you can get it out, I'll try to talk you through it. Just grabbing mine here. So it's under, I believe it's under second distribution. Yeah, normal CDF, sorry, not norm dist, that's something else. Normal CDF. And that's second distribution. Can you tell me what you see there?
Second distribution. Oh, okay. And then it's normal CTF. Okay. So I don't think I have the correct numbers in because it says -1 E99.
Okay, so yours is lower bound, I believe. So let's go -1 E99. What's the next number that it's asking for? Does it say like upper?
There's no value for upper.
All right, let me look online here. TI 84, is that right?
Yes.
Okay, let me grab it here. No, it's not giving me what I want. Images. Here's what I'm seeing from the internet. Is this, just let me snip this in. Is this not, do you not have something like this? Lower,
I have
upper?
I have that. I just don't know how to input the values to get the correct.
Okay. Yes, let me talk you through that here. So the lower, so let's start with the upper is 28 because that's the right. The right is always the upper. Now the left is like at minus infinity. So you can't put minus infinity into your calculator. It doesn't understand that. So what teachers tell you to do is go -1 e to the 99. That's meant to represent left. The mu, or the mean in your problem, is 49. And the standard deviation is 7.
Okay.
So that should, if you do that correctly, it should give you 0.15. I'm sorry, 0.0015.
I got 0.00134999.
Okay. Pretty close. Maybe yeah, okay. I mean, is that okay? I mean, is that
Yeah, that makes sense.
okay? Now it'll make more sense for the next ones. I'm sorry that just I didn't know quite exactly what we're doing. Now I got it. All right. Let's do number 3 next. This is more like number 1. You got to be careful though. It is asking for percent, not a decimal, but let me grab the next question here. So number 3, we will do number 2. It says, what percent of beardies produce more than 56 grams? So here's your normal curve again. 49 is right down the middle. 56 is kind of over here. So more than means to the right here. So here, we want the area here. Right, so you see how like this goes out to positive infinity. Like we don't know how far it goes, but it goes out to positive infinity. So this 56 is your lower and your infinity is your upper. So in your calculator here, I won't step it any of it. It's the lower bound. You're gonna have to go back there. Your lower is 56. Your upper, what they like you to do is 1e to the 99 is your upper. And when it's infinity. And then when it's negative infinity, you put a negative in front. The mu is 49. And the sigma is 7.
Okay.
And your instructor says to graph the normal distribution. So they want to see where you're shading. They want to know that it's upper tail. Sorry about that. That's not good. Here we go. Do you have an answer from this?
Okay, let's see. 0.1586.
Let me check that. That sounds right. I know I should be doing this. That's not going to work. Okay, let's just go with that. What's more important that kind of the steps here. The numerical values will change. All right, so that's that is that. All right, it's number 2. So there's 2 types of questions they can ask you. The first type we've looked at is where they give you a number that is along here. The other type of question they can give you is an area. And that's what you have to be able to distinguish between. So that's what this problem is asking for. So when it says 12th percentile, it's saying the area over here, this area is 12% or 0.12.
Okay.
So your calculator has an inverse norm thing. Let me go find it. It's number 3. So inverse norm, number 3. And your TI 84. Norm. Let me find the order. Does it just give you area, mu, and sigma and paste? Is that what you see?
When I try to do the normal.
No, it's inverse norm this time. Inverse norm.
Oh, inverse norm. Okay, so 3. It's area and then the
Mu mu and then
Yeah.
sigma? Okay,
Uh-huh.
great. So your area is always the left area. So in this case, it's 0.12. Your mu is the same mean, it's 49, and your sigma is 7.
Okay.
So just paste that in and tell me what you come up with. And what you're getting is the number that's right here.
Okay. Wait, let's see. So and then it's the left tail, correct?
Does it ask you for that, or is it just ask you for area?
It says area and then it's the 49.7 and then tail.
Okay, left. Yeah, you want to specify left tail.
Okay. 40.775.
Okay, so 40.775. Good. Now let's go kind of like this is our check now. So again, normal distribution here. Here's 49. Here's 40.775. So let's say we want to find the area this time. So the
Okay.
area, when you want to find area, you use the normal CDF. So we want to find the area in this tail. So your lower is minus infinity. That's minus 1e to the 99. Your upper is this 40.775. Your mu is the 49. And your sigma is 7. So I want you to put that in again for normal CDF. And you should not be surprised when you see the answer. But we'll talk about that here in a moment.
0.11999.
0.1199, kind of a lot like 0.12 or 12%.
Mm-hmm.
Do you see that that's what we were starting with in the previous problem?
Yes.
Okay, so we're going to do the same thing for the 88th percentile. Because I want you to see it both ways. I want you to see that you're, one way you're getting the area, the other way you're using the area in the curve. So let's look at the 88th percentile here. So here's your normal curve. What it's saying is that left of this number, the area in this normal curve, area is 0.88. And
Okay.
you want to find the value down here. That's why our instructor says graph it each time, but maybe it's not been clear, but now it will be. So whenever they give you the area, that's when you use inverse norm.
Okay. So area.
So your area is 0.88. Your mu is 49. Your sigma is 7. And again, it's left. It's left because you literally look like, well, what is it? Well, it's left of that line. It's left of that thing there.
57.22.
Okay, like that.
Yes.
All right, good. So now let's pretend like we were given 57.22. And we want to know, we're given 57.22, and we want to know what's the area to the left of it. So whenever we're given a value along the axis here, that's when you use the normal CDF. Like that's the main thing I'm asking you to try to take away from what we're talking about here is when do you use inverse norm, when do you use normal CDF? Okay, so the lower bound is minus infinity.
Mm-hmm.
The upper bound is 57.22. And the mu is 7. I'm sorry, 49 and the mu is 7. Go ahead and type that in. Normal CDF.
Zero 0.879.
0.879, pretty much 0.88 or 88%. So if you recall, we were given an area of 88.88, 88th percentile, and we got 57.22. When we use that value to find the area, we get 0.88.
Okay.
For number 4, I'm not real sure how to answer this because the interquartile range is not defined on something like this, unless your instructor is using some other formula. Do you happen to know what he might be referring to here, he or she?
I do not.
Okay. You might want to ask.
Yeah.
I
Okay.
could guess. I can guess here, but I don't know what it would be. Okay. We got time here to probably do the last 3. The 6. I'm sorry. 6 is related. Well, 5 is like more of just a word question. Let me answer 5 verbally. So the 5 is about the difference between inner and intra. So inner is when you're bounded between two things. Intra is like between or outside. I don't know. It's more of a word answer. I don't think it's important for you to learn. Sorry, I shouldn't even brought it up. 6 we really can't do without knowing what 4 is referring to. So let's go to number 1 on this continuation of this insanity of bearded dragons. Bearded dragons. I don't know. Okay. All right. So do we know how many that Riley had to start with? Was that somewhere else?
I think it's the question on the first page. 45 males, 45 females to work with, live in 3 long rows of 30 tanks.
Okay, so let's say 90. Let's say there's 90 to start with. I don't know. We're gonna have to go with some number here because I don't know what it's referring to.
Okay.
So if 95% of, it's like a general statement, it's like 90% of these bearded dragons appear to be friendly. So how many would you expect to be unfriendly? So there's 95% that are friendly and 5% that are unfriendly. So you take those numbers and you multiply by the total. So 0.05 times 90, 4.5. Or if they wanted friendly, 9.95 times 90, you have a calculator, whatever, 85.5 for that.
Okay.
So they're just asking to take the percentage that are, it's really an expected value problem, but they don't say it that directly. Question 2. What is the probability that out of 8 beardies, half are friendly? So this is a binomial distribution problem. You know that because they're either friendly or not friendly. For binomial distribution problems, you need a P and an N. So your P is the probability that they're friendly, 0.95. The N is the number that they're selecting, 8. And there's this last one, which is X. That's the condition here, half are friendly, 4, like that.
Okay.
Now on your calculator, you can use binomial distribution. Have you been doing that in class?
I think we did at one point.
All right, I am trying to find it. All right, so it's under second distribution. It's down under. So problem is there's two options. There's 0 and A. Maybe this is not clear, but binomial PDF.
Oh, okay. A.
Yeah, no, A is CDF. There's a big difference. Do you know if you're doing it this way or if you're supposed to do it by hand?
I think he wants us to do it by hand, now that I think about it.
All right, so ignore what I just said for the last 30 seconds. All right, so you got to do the NCR P to the, I think it's R.
Mhm.
You can tell I never do this by hand. Binomial distribution formula. Yeah, so it's P to the R, or I guess X, sorry. I guess books use X. You wouldn't believe how many variations there are on all this stuff. Universities
Yeah.
and classes. Q to the N minus X. So yours is 8, choose 4. 0.95 to the 4. And then 0.05 to the 8 minus 4 power. Do you remember where 8C4 is in your table or in your calculator? How to do that?
84.
It's under a math, herb, PRB. And then it's the NCR.
Oh, yes. Okay.
And you have to put the number in first, 8, NCR 4. You get that number, whatever it is, and then you multiply by the other two here. So that's 70 times the 0.95 to the 4th, 0.05 to the 4th.
So 3.56 E negative 4.
Sure. Let me. Yeah, that's right. You'd want to show it as a decimal, so you want to say like 0.000356, maybe something like that would be good.
Okay.
All right. We do have to stop here. I apologize, but I know there's more, but this hopefully this helps get you
Yeah,
through tomorrow.
definitely.
And thanks for letting me help you all semester. Obviously I'll be
Yeah,
around
thank
next
you.
semester, and hope you have a great holiday with you and your family.
Yes, thank you. You have a good holiday as well.
Thank you. Thank you so much. Have a great night. Bye now.
Bye.